So here we have it. Our first target for the new year, as well as our target that is for our first unit for the new year, which has to do with equations. And you're going to see some underlying themes. But the first question that we are going to talk about is the essential question. This is the goal. This is, but by the end of this set of notes, by the end of the week, we should be able to answer this question. So how do I determine what value, which is an important word, makes an equation true? So we're talking about values, which are numbers, and they could be fractions, decimals, or positive, negative numbers. In this case, we're just going to be working with positive numbers. And an equation is a problem with an equal sign. And we'll get into that in just a moment, why that is important. Right before break, we worked on expressions. We worked with expressions in Unit 4A, which was problems without equal signs. We could simplify, but we couldn't solve. This time we're going to be able to solve. So let's get into it. The first thing we want to do is we want to make a checkbox so that if we can meet learning skill number 1, we'll check it off, okay? So let's talk about what is the first thing that we have to do to meet this target. This is the goal, is meeting this target. And that goal we wrote in the form of a question. So here's the first target, okay? Understand that solving an equation, so the first thing that we know we have to do is just to be able to understand. We don't actually have to like solve anything or do anything. We just have to understand something. So that is the first goal we're going to work with, the first learning skill. Understand that solving an equation, so we're solving an equation, we're looking for x or y, answers the question, which value makes the equation true? So in this case, we're working with equations, and we're talking about values, which are numbers. Remember, equations are problems with equal signs that are true. That's really important. What values make the equation true? Well, what does it mean if we're talking about equation being true? So let's talk about this. Back in the Roman times, which you guys will learn about, they used to weigh money. They didn't have coins like us where we can just simply get out a nickel or a quarter. They had to weigh it to make sure that they were all the same amount. So they had these scales. I'll put a little bowl here and a little bowl here. So they had 2 scales. Basically what would happen is they would put an item that they knew for sure that there's a certain weight. So say this is 5 ounces. And what they would do is they would put your coin or your coins, however many you put in there, however many you're paying with, and they would make sure that those coins, if you were paying 5 ounces worth of gold, they would make sure that those coins, that your scale was equal to each other. So it had to be, if they were at the same height, then they would be equal to each other. That's where we get the equation. So typically, when you look at these scales, sometimes if one side was heavier than the other, it would be lower, and the lighter side would be up here because it would get taken up. So this is the heavier piece right here, right? This heavy piece. And this is the lighter piece. This is less weight. Okay, so the heavier you are on one side, it would pull it up on the other side. It's kind of like a teeter-totter when you're little. You may have played with those if they had them at school, at the park, where, you know, one person would get on one side and one person would get on the other side, and the bigger person, whoever that would be, would make that teeter-totter go down on one side. So what we want to do is we want to level out the teeter-totter. We want to level out the scale so that it's the same on both sides. Okay, it's the same on both sides, and that's what makes an equation true. So what does it mean when an equation is true? I want you guys to write this down. Catch this. This is important. If an equation is true, that means it's the same value or the same number on both sides. Okay? Same value on both sides. I'll give you an example. If I have 7 on one side, if this equation is true, that means 7 equals 7. That is true. Okay, if I solve it and I end up with an equation that has 4 on one side and 9 on the other side, that is not equal to each other. That is not true. So I'd put a line through it. Okay, not equal to each other. So the whole question, the whole goal of our learning skill number 1 is that you understand this, that if a value is true, an equation is true, or a value makes the equation true, that means they're equal on both sides. So if you, and we'll put that here, we'll put that word equal, okay, equal on both sides, okay? So if you understand that, you can tell me, oh yeah, if an equation's true, that means both sides are equal to each other. They are balanced. Right? If you can tell me that, then you already understand learning skill number 1. That is the gist of learning skill number 1. It's just that the equations are the same on both sides. That way they're balanced, right? So we can add that word on there if you want. They're also balanced. That's important, okay? Same value on both sides. They're equal. They're balanced. It's the same thing on both sides. So this is the important definition that you need to have down on your paper right now. Okay, the pictures would really help you, so don't shy away from the pictures. This picture would be true equation. This would be a true equation. Right? The other two are not true equations because they're not balanced. They're not equal. Okay, so then let's move on to the next piece. Now we're going to move on so that you can understand, and I'm going to take a picture of this so that we can have it for later. We'll put it on the website. But let's go ahead and talk about the second piece. So I'm going to go ahead and shrink that up, and I'm going to bring this, make it a little bigger. Okay. So here's our second learning skill. So if you were good with the first learning skill, you understand that both sides need to be equal. If an equation is true, then make sure you mark that. Now let's talk about the second skill. It says use substitution, and you guys use this word in working with expressions. So you should know that already. It's when you substitute or you switch a number for a variable. Okay, so there's a variable there, but you can switch it out and put a number in there. Okay, so the whole goal is use substitution to determine if a given number makes the equation true. So we're basically going to test. And we're going to ask ourselves, is the equation true? That's all we're doing. We're just going to test these things now. So learning skill number 2 is, okay, we understand that in order for an equation to be true, they have to be equal on both sides. Now let's test it. That's what learning skill number 2 is, just the testing of it. Okay, is it true? All right, so let's look at the first example. It says, does the value g equals 5, so you notice value is just the number, g equals 5, make the equation, and here's our equation, true? That's all it's asking us. Is it true or not? Okay, so we're going to write out the equation, 3 plus g equals 8, all right? And this is really important right here, this middle number. It's our balance. Is it true? Is it really balanced? Well, let's figure it out. So we said g equals 5. So instead of g being there, we're going to substitute it. We're going to write 3 plus 5. It's really important you keep writing your equal sign, okay? And on the other side, we have 8. So we have to figure out, okay, are both sides equal to each other? Well, if we add 3 plus 5, we get 8. So what we're saying is 8. We have 8 on one side of the balance and 8 on the other side of the balance. And that means that they are true. They are equal to each other. So we can see, yes, this one is true because 8 equals 8. So that one's good. We put a little check mark there. See my little check mark to say, oh yes, those are true. They're equal to each other. Okay, let's try another one. Don't let these words scare you. It's just asking a question. Which of the values, which I spelled that wrong, which of the values make the equation 9 minus k true? So this time we're working with more than one value. We have this one and we have this one, and we have to test it. We want to know which one of these makes this equation true. Okay, so the first thing we're going to do is we're going to write our equation, 9 minus k, and on the other side we have a 5. Okay, so remember, we want to draw our line so we can show that balance between the two, or the lack thereof. Okay, so for this one, really quick, I want you guys, you can draw a little balance here. And you can show that they are the same. They're exactly the same height. Okay, that means they're balanced. All right, let's look at this one. Let's go back. So 9 minus k on one side and 5 on the other side of the balance. Okay, so we want to know which one of these makes it true. So we're going to test this one and we're going to test that one. All right, so what I'm going to do is I'm going to actually, let me erase this and let me draw or write two equations out so that we have them both. Okay, so we have 9 minus k equals 5 right here, and 9 minus k equals 5 right here, because we're going to test both of these equations. So I'm going to draw a balance there and a balance there. Okay, so let's go. The first one, we want to substitute 5 in there. So we have 9 minus 5. And we still have our equal sign. Don't forget, that's really important. Equals 5. Okay, well, let's see if that's true. Well, on this side, 9 minus 5 is 4. Let me extend that. So does 4 equal 5? No, it doesn't. That's not true. There's no way that could be true. So for this one, we want to draw a little scale. And this time we'll do one side, the lower side is higher, and the bigger side is lower. That is not true. So we're going to say not true. Okay, they're not equal to each other. So we can draw a line through the equal sign. They're not equal to each other. Okay, let's try the other one. So the other one says, not this time k is 4, so we're going to put a substitute of 4 in there. 9 minus 4, does that equal 5? Okay, 9 minus 4 is 5. So yes, this one is true. So let's draw ourselves a little balance to show that it's true. So we have our balance, and we can show that these little bowls are the same height. Yes, 5 does equal 5. We are good. So this is true. So in this case, when it asks us which value makes the equation true, the value is 4. That's what made it true. All right, let's do two last ones. So for this one, in this case, you're like thinking, uh-oh, Ms. Hernandez, there is a fraction. I do not like fractions. It's okay, I promise. It's not as hard as it looks. So let's read the question. Is h equals 20 a solution to the equation? So this time they're asking the same thing. They're just asking, is it true? It's just a different way of saying it, but make sure you pay attention to these words because they might ask it in different ways. But once you see that h equals 20, just put it in substitute, okay? So let's go ahead and do this. Let's rewrite this equation, h equals 20, and we know it's an equation because it has an equal sign, okay? It's the same thing we're doing, it just is worded a little bit different. So in this case, it's asking us, does h over 20 equal 0? Well, our h was 20, so we're going to say 20 divided by 20. Is it the same as 0? Well, if you know anything about division, 20 goes into 20 one time. So our final answer is 1 equals 0. Is that true? No, it is not true. This is not true. So I could literally put a slash there. It is not true. 1 does not equal 0. And so what we're going, and 0 does not equal 1. So when the question says, is h equals 20 a solution to the equation? We're going to say, no, it's not, because 1 does not equal 0. Okay, so don't let that fraction scare you. It just means division. It literally just means divide. That's why I drew this arrow right here. Okay, last one. What value, so again, they're asking for a number, makes the equation 7m plus 1 equals 36 true? Ooh, that's hard. Okay, so what I want you guys to do, I'm not going to actually tell you the answer, but I'm going to give you a few pieces of advice. First thing I want to do is it's asking what number, so we know we have to put a number in for m. Okay, I want to remind you of a couple of things. Just like with expressions, if a number and a letter are stuck together, that means they're multiplication. So 7 times m plus 1. Well, let's go ahead and do it together. We might as well. We're here. And this is if you missed some notes. So let's talk about it. 7 times what plus 1 equals 36. So in my head, I start thinking to myself, okay, well, what does, I always go to fives because that's the easiest for me. You can ask yourself, what is 7 times 2? What is 7 times 3? I always start with 7. I always start times 5. So 7 times 5 is 35. 7 times 3 is 21. You're definitely just guessing and checking at this point. We have 14. So we need to get to 36. So you notice here 7 times 5 equals 35. So what if I put that in? Let's try it. Let's substitute in 7 times 5 plus 1. Does that equal 35? And you literally just start, or 36. You literally start guessing and checking. Well, I really am good with my 5s. That's why I always start with my times 5s, then I move up or down. Well, I know 7 times 5 is 35, and if I add one more, hey, look, it's actually 36. So on this side it's 36, and on this side it's 36. So I can say, when it says what value makes the equation true, I can say, oh, this value right here, when m equals 5. So the question was what value? I'm going to say when m equals 5. That's what makes it true. All right, you're going to be doing some practice. Make sure you go to page 2 of our class kick and then work on your IXL also for extra practice.